Well, we have a fun little project with the 73 Mach 1 this time. The other day, after we came back from a car show, I went to start the engine. It cranked over and tried to fire perfectly, but as soon as I returned the key to the run position, the engine died. That happened a few times. I went under the hood and I moved the battery terminals, thinking that, gee, I know that there's corrosion on one of those posts. Shouldn't cause that problem, maybe it does. Went back inside the driver's side of the car, fired right up. Imagine that. Well, the next morning it didn't. It would crank, try to fire, but not run. So this has an aftermarket MSD ignition system, high performance, and it's electronic, not points and condenser. And down here we have the MSD 6AL electronic ignition module. L in the name 6AL means that it has a rev limiter. Well, first thing I did is I unwrapped some of the sheathing for the wires, so you see the wires. Then I had Linda put the ignition key in run position, and I checked the big red wire and the smaller gauge red wire. They are both supposed to have 12 volts of power. The big red one, just straight battery voltage. The small red one, switched power. Well, big red one is good, and I can see where it goes to the starter relay, to the positive side of the relay. This red smaller one, I put a voltmeter on it, and it is only reading 10.8 volts in run position. So that tells me that whoever installed this, instead of using 12 switch volts, either ran that red wire back to the wire that used to feed the ignition coil, because that's from a resistor wire, or they went to the I terminal of the starter relay. Is what that does in run position. This has resistor wire voltage. About 10.8 would be what it was with the key on run position. During cranking, you get full battery voltage through there, not 12 volts, because battery voltage drops to about 10, 9.5 volts around there. And so now what I'm thinking is that the wiring between the starter relay and this red, smaller red wire is fine, because it tries to light off. But if he tried to connect this red wire in run position to another wire up along in here, there is most likely an intermittent open circuit, one that hasn't bothered us until now. So yesterday what I did, I went to the other side of the engine. I took apart the loom casing, which was a real pain because whoever did the work did a nice job, but they wrapped the plastic conduit with electrical tape along its whole length and made it really difficult for me to pull anything apart and inspect. I didn't see anything unusual, but I also did not see the thin red wire in that loom. There's 3 other looms, because there's a few aftermarket ones. So what I decided to do was just bypass all that. I picked up a standard Bosch style relay with the socket. And what I'm going to do is attach this relay to inside the car here somewhere, the engine compartment. I've decided where yet. Black wire goes to ground. White wire is the trigger wire. I could run this to the starter relay I terminal, and whether the car is running or cranking, it will get enough voltage to close the contact points inside here so that the blue and yellow wires will both become hot with 12 volts. Now one of them goes to a 12 volt source full time. The other one only comes on when there's voltage applied to the white trigger wire. And so it is going to be the load side of the higher capacity current that'll be running to the red wire for the module. And that should fix the problem I'm having. Now, I'm not going to be doing anything fancy. I'm not going to be using a soldering gun, but what I am going to do is use shrink wrap. Some of them will be maybe spliced into existing wiring. Other times, I brought a collection of electrical terminal eyelets and other terminal types out here with me. So one way or another, I'll be getting this done. I have Linda record what I'm doing step by step so everybody gets a chance to see what's going on. The first thing I want to do is I want to take a look and see where I'm going to attach this relay. This is a plastic housing, so I can't use it as the ground, but the eyelet here with the screw going through will be going into metal, so I might just put an eyelet on a black wire and ground it right there. Make it real easy. Okay, we're going to pause while I set things up and we'll turn on in a moment. I found on the starter relay where I could remove the securing nut for the I terminal. That being start this for ignition. There are currently two other circuits hanging on there. I'll add a circuit, screw it down, and then I can press this in place. So the way I'm going to do this, the white wire is the trigger wire. The first thing I'm going to do is find where I put the eyelet. Oh, Linda found it rolled on the floor. This is a small piece of shrink wrap tubing. So I put it way down here, away from where I'll be working initially. Use a pair of wire strippers to strip the insulation off the end of the white wire. Now, I don't have to, but I like to twist the ends before I do anything with them. And then I'm going to simply put the wire inside the round-headed terminal and then crush this so that the wire is secured inside. Then I'll tug it to make sure I don't feel any movement, and I don't. Run this all the way down here. The other end of this blue sheath is already shrunk wrap around the terminal, making it water resistant, if not waterproof. Then I take a heat gun with a special loop back. Let it heat up for a second. Then I simply put this in here and let the heat do the work. So now what I have is a nice, clean, water-resistant, if not waterproof, seal. Inside this shrink wrap is an adhesive that sticks to the rubber insulation, plastic insulation of the wire underneath. That's what I wanted. Now, that's for the I terminal. What about ground? Well, I have something in mind for ground. It's going to take the same kind of solution. Got a piece of shrink wrap. Now, the one tube is way too long for what we need. So I'll just cut off a little piece of it. Put the rest away, or aside, because I'll be using it again in a few minutes. Take the black wire, run this thing all the way down, and then try to find an eyelet that will be the proper size for that as well. Whoop, not in here. In here. I got so many kits with electrical. That's a little bit too big. These used to be sorted in little bins of their own, but I dropped it and these plastic separators popped out and things got mixed up. So there's 580 of those things in there, minus a few that I've used. I'm not about to go resort them all, so I just live with it. And like the white wire, I use this strip of black wire. Push this through. Crush it. Whoa. That's got missing sleeve. The metal sleeve that's supposed to be back here isn't there. I have a collar up here, so I'll twist it real tight, see if I can shove it through that way, because that will work. This is a very low amperage ground. Nope, I've got another eyelet. That one was not formed correctly.
That one? Oh, yep, you're right. You're right.
I'll be more careful with my next selection. Huh, that one's the same way. It must be that I got two different design terminals in here. No, this would be a good size. Same thing. Let me have Linda pause for a moment. I've got to sit down. Well, I found another eyelet. Blue sheath, but a little different size eyelet. That will be fine for the ground. I crushed the crimping part. It's secure. I tugged on it, nothing pulled out. So try to get this on. There we go. Shrink wrap it. These get really hot, so when you use them, keep your fingers away from the heat source. What's nice about this is it has a small deflector, so heat that comes out with air this way bounces back and comes back. So I can do two sides at the same time, which is kind of nice. Yeah, that's cooling off. A little bit warm. Now, I'm going to check with my photograph I took of the pinouts for these relays and make sure of what plugs in where. Here we go. Trigger wire goes to 86. 86 is very lightly stamped into this plastic housing, very lightly. Let's see if it's over here. I saw it earlier. I know where it is. Where the relay go? The black relay has it marked.
The black relay, isn't it plugged into it? Oh, there it is. Okay, it was on the front.
That's there. I'm talking about it's actually stamped in here.
Okay.
So I'm looking for 86. There's 85. 87 here. 86. It's the bottom vertical one.
The blue? No. Yeah, blue. Yep.
The one across from ground.
It's down.
That's 30.
Oh, it's not 86?
And that's 87.
Oh.
This is 85 and 86. $85 there, black. 86 trigger. So that means that the blue wire goes to 30, and 30 is supposed to connect to the power source, and then 85 goes to what they call the load, or where's the current going. This goes to splice into the red wire for distributor. So for this, I already have one wire coming right off the starter relay positive battery terminal. I'm going to use a Scotch lock to put this in splice, and that will be perfectly good because we don't drive this car in the rain, so I'm not worried about things getting wet or not getting wet. There it is, Scotch lock. And what I'll do is I'll put this wire in here. It only goes in so far because there is a block inside here, and then the power wire that's out there currently is battery voltage, gets put in this first area, as a pass-through. So I'll do that in just a bit. This red wire is actually a spare for other purposes, not used by this relay. The center spade is not even there. But that leaves it to the blue wire to carry the load over to the starter circuit. And I'll probably use a Scotch lock for that also. And that'll work out perfectly well. Again, because we do not drive this thing in the rain or the snow or the ice. So we're not going to be getting corrosion in these connectors from wet sources. Okay, now, time to get her done. I need to provide a hole so I can use a hold down screw to put this into the side fender, inner fender, so I can lock that down. Put these away. Okay, I finished drilling a small hole in the inner fender to mount the relay. For the black wire ground, I have taken an eyelet terminal. I have a screw going through it. It's going to go through the mounting hole, and then I'll use that to secure the relay onto the inner fender, as well as provide a ground for the relay. So that's how we're going to be doing that. Okay, I have attached this. I've tightened the screw. The relay is now mounted to the inner fender just behind the starter relay. And the black ground wire is being held in place by this retaining screw for the relay housing. Now, I'm going to take the white trigger wire and attach it to the starter relay I terminal. Okay, the I terminal on the starter relay had 2 terminals on it already. I added a third, which meant that this nut to tighten everything in place would have to go down enough to leave enough of the screw for this slide over terminal to fit on. The slide over terminal goes to the ignition primary circuit and provides full battery voltage when cranking the engine over. I just press this in place. It is secure. So I'm happy with the white terminal now being attached. Now I need to take care of the blue and yellow connections. The blue one is going to get spliced into this heavy red wire. It's going straight to the positive terminal of the starter relay. I want full-time 12 volts available for that. I'm going to plug this in to make sure I have enough length to do that. Barely. It'll be enough. The first Scotch lock I will put on the outside of the two runners. And it is in place. Then the blue wire from the relay, I push into position. I check the depth of the wire to make sure it went all the way into the splicing blade. That feels good. Pliers. And there's a small blade I pinch down into the splice lock, and it cuts the insulation of the two wires, and because it's metal, it causes them to share a circuit. I pull on them both, they feel secure. There's a little latch I'm going to flip over here that keeps it together. Sometimes I have to use pliers to get that latch to secure. But once it's done, it's done. All right, I gotta pinch a bit more, apparently. There. And I'll do the same for the yellow wire going into the small red wire to the module. Yellow wire didn't want to go in. Don't know why. Red wire's in place. There. I went ahead and spliced the yellow wire from the relay to the small red wire that is supposed to carry current whenever the engine is cranking or turning. That little bit of current goes through this yellow wire What I do with this plastic conduit is I will use it to cover some wires. Then at the ends I'll use some black wire tie to tighten it down, and maybe partway back I'll do it just to hold things in place. So if I ever have to get back into that conduit to work on some wiring, I simply have to cut the black wire tie, expose the wires, do what I gotta do, then tie wrap it back up. Now that's not to say that using black tape along the whole length is wrong. It just makes it really hard for the next person to work on the system. So what I did, I needed to make sure that I had 12-volt battery power to two different wires going into this module. The one is a relatively large diameter red wire that my finger is touching right here. And I tracked that back and found that there is a terminal on the positive battery side of the starter relay leading there, so that's fine. The other wire was a much smaller gauge red wire that my finger is laying against right now. That one needed to be 12-volt switched power. Well, what I found was that when I put a voltmeter on here, with the ignition switch in run position, I was getting 10.8 volts, not 12. So that told me that the other end of this wire is connected to the old ignition wire, which was a resistor wire that lowers the voltage from 12 down to a lower level, 10, 9.5, depending on the length of the wire, which is not how they're supposed to be hooked up. I suspected that the problem I was having was between here and the ignition switch. And the reason I suspect that is because when I would go to start the engine, it would fire off. But as soon as I returned the ignition switch to run position, it would die. So it told me that the ignition system is working properly as far as firing the signals to the ignition coil, from the coil to the distributor down to spark plugs, because it would start. It just wouldn't run. So I suspected that the problem was the circuit feeding the small red wire. So I started to undo all the wiring, and I started running into all this black tape, and I decided, you know what? There's an easier way, just as effective. So what I did was I purchased a relay similar to this one, which has a couple of wires. Black goes to ground, white goes to what's called a trigger voltage, blue goes to 12 volts power, yellow goes to wherever the voltage is supposed to wind up, the load they call that. In this case, this yellow wire will be feeding into the smaller red wire. So I hooked up a relay similar to this. For trigger voltage, I went to the I terminal on the starter relay. I did that because it was a short, convenient distance from here to where I put the relay and the wiring. And anytime the engine is cranked over, we get full battery voltage through the wiring of the automobile. And in run position, we get the 10.8 and 11 reduced voltage. That's all we need to trigger the relay to then send 12 volts from the blue to the yellow wire and into the module. So I thought that was pretty cool. I hooked it all up. The engine fired up and ran perfectly. Then after I let it warm up a bit, I turned the ignition key off and the engine kept running. Oh boy. Did I get a delay relay? I didn't think so. So I came back out. I brought a bunch of different pieces of equipment, the power probe, test light, a volt ammeter with an inductive ammeter clamp. I started testing, and what I found was that once the white wire had been activated by the I terminal, even when the power and the ignition switch got turned off, there was feedback power in the order of like 1/4 volt and 6/100 of an amp still flowing. Very low voltage, low amperage, but enough for this relay to stay engaged. And so it kept feeding power down to the module and it kept running. All right. How do I fix that? Maybe the relay was too sensitive. I brought out a different relay, different manufacturer, swapped it, behavior was the same. Well, I'm not going to start hunting all over for a relay that is low sensitivity or high sensitivity. So what I decided to do was to change my source of the trigger voltage. So I went over to the carburetor, which has an electric choke, and I have wiring going to there that's coming from the windshield wiper power circuit. Anytime the ignition switch is on, the power is on for the windshield wiper. Anytime it's in crank position, the power is on for windshield wiper. So that was a perfect place to pick up voltage. I already had it there. So I put a splice in here, a little Y connector, and then I ran a little red wire. I'm going to make this nice and pretty later on, down to here. And when power is now applied to this white wire, the relay comes on to get power. I'm supposed to get it, but when the power is taken away from the white wire or the key is turned off, the relay open circuits, no more current to the ignition system, engine stops like it's supposed to. Now, once I corrected or enhanced the wiring, I thought it'd be nice if I could demonstrate old way, new way, but I couldn't get the old way to act up again. I don't know why. All I know is I fixed the problem, which I'll demonstrate. I'll plug in the cable, the wiring that leads to the electric choke to the white wire terminal. Okay, it's plugged in. Then I'm going to use this test light to go on the yellow terminal, which feeds the small red wire on the ignition module. I'll then take my power probe and apply 12 volts of power to determine where the white wire is, and watch what happens to the light here. Now we have light and 12.0, 11.9 volts. Okay, that's great. Oh, and now the yellow wire, when I turned off the voltage, the yellow probe shows no voltage. It turned off like it's supposed to. So now what I'll do, I'll keep this test light on the yellow conductor inside the connection itself. I'll have Linda turn the key to run position and show we get voltage. Okay, then come on, take a picture of that. And you see the test light is on.
Can't see it from here.
Oh,
Okay, it's on.
okay, go ahead and now turn off the ignition key. Okay. And now there is no power to the test light. So that worked. It's a more secure circuit than I had before. So now what I'll do is I'll start making this all pretty, put it inside conduit so nothing is exposed like it shouldn't be. And then we'll fire this thing up and take it out on a test drive for a different project, which I'll explain in an upcoming video, where I'm testing for acoustical vibration in the car. Okay, we'll be back once I have this all cleaned up. Nice and... Okay, I have put conduit over the wiring in the major areas to keep the wiring from chafing on any metal or other parts of the engine. The wiring that is exposed is right at the connector, nothing rubbing on it. And over some other areas where I need to be able to pull it apart quickly to diagnose if there's a problem. But the major stuff I need to get protected, I now have conduit in place. Makes it look better, helps prevent chafing. Where wire insulation gets chafed away and the wire touches the ground, the body or something, or a short circuit with another wire, that can cause all kinds of problems. So I've got a little more conduit to fix on the other side of the engine where I took some of the loom apart when I first started tracking this down. I'm going to re-conduit wrap that and then take this out for a test drive.